Now we are going to design the flat slab. So go to the design tab. In order to design this slab, we are going to give some parameters for design. So first we have to define design code. This time we are going to design as per Eurocode Singapore National NS. And go to the partial safety factors for material properties. So if you click update by code, the alpha CC value will be changed as per Singapore NX. And go to the modify concrete material. So this time we are going to use this class A for rebar and column as well. And go to the mesh slab, mesh design, and if you click the serviceability load combination type, load case will be classified as Eurocode, and they will be automatically classified when using auto generation. So we already generate the load combination using auto generation, so program automatically classified. And go to the slab wall load combination. We can select the desired load combination during the slab wall design. And next, design criteria for rebars. So the basic rebar data as seen in the above dialog box is applied to all the slabs. In this time, we are going to check off this because we want to apply different basic rebar data to different slabs. So rebar, I'm going to use P12 type. Click OK. And let's check the fracture design results for slab elements. Go to the slab fracture design. So here, if you click element method, design result will be displayed by the internal forces, which are calculated at each node of the element. And if you click this average nodal, design result will be displayed by the average internal nodal forces. So this time I'm going to use this method. I'm going to see the top and click the rebar. Also, you can see required rebar area or resistance ratio, etc., flexural moment. So once you click apply, you can see the design result here. So also the legend, the graphical result is on your right side of the screen. And also you can see the design force at each node. And if you click design result button, you can see the text format for design result. So you can easily check the process of the design. And once you click update rebar, the rebar data is input to your model. So now fracture design is done. So we are going to see this slab fracture checking. In order to do that, I'm going to give the different rebar data. So go to the properties. So just delete all the rebar data we just designed and give the new rebar data. So I'm going to give the T1 S1 for 150 space and 2 300 and 3. I'm going to give P5 type for 400 space. And for bottom, we are going to change the space, and this one as well. Delete all the rebar data and give the new rebar data. Also bottom direction too, we're going to change this spacing for 200. Now you have new rebar data in here, but it's not defined yet, so we're going to define this using these subdomains. So give S1 subdomains to S1 rebar data. So now you have S1. And select S2, give the S2 rebar data, and S3 as well. So this one, we have to define the 200 spacing. So select all plate and give this bottom rebar data. And this one as well, direction 2. And other thing we can delete. Now we can go to the slab fracture checking. So same options, we're going to check the slab fracture result. So click apply. So you can see the design result of your model. Also you can see the resistance ratio, and if you click design result, also you can check the text format of your slab. Also if you select just only these subdomains and go to the slab fracture checking, and click apply, you can see only selected materials here. Now we are going to check the slab shear checking. So in this option, by force method, the program takes the axial force in the column supporting the slab as the shear force. And if you select this stress method, the program checks shear using the result stresses obtained from the analysis. So in this time, I'm going to see this force method. So click apply. So you can see the shear. And if you click values, you can see also the value of the shear checking. So the critical line you can also see, and the ratio you can also check for your design.